just joining us, I have sent out the Google Classroom code. You remember, right? So, guys, let's not have a private chats, please. Please, let's not have private chats because it will disturb other people. Né? So, for those who are just joining us, guys, please join our Google Classroom and enter that code right here. That code, which is 3YNC. Okay, let me send it again for the last time. Okay, but I'll send it again before the end of our lesson. Né? But for now, here's our Google Classroom. I will show you how you guys can join so that we can all join and have fun there by the Google Classroom. Né? So let's start with our lesson. All right, everyone. Thank you so much for joining us again today. Lovely to meet you. I see a lot of familiar faces. Thank you guys so much for coming back. It means a lot for me and for our school. Thank you guys so much for coming back, and tell your friends to come join us. So in today's lesson, it's Mathematics Grade 8, presented by Miss Tabo. Thank you guys so much. Welcome. So in today's lesson, we'll start our lesson by most definitely completing our home activity from yesterday, problem solving. You remember that, guys. Problem solving, it's really nice. Just think of a real life situation. In that way, everything will be fine. Everything will be happy, actually. You'll be happy. Everything will be good. Like, it's going to be amazing. Just think of a real life situations and how you would tackle that situation in real life. Not in a book context, but just think of a real life situation. And then when you come back to read the questions, you'll actually see that actually they are the same. I was just thinking too hard. That's all, because it's really easy. Problem solving is really easy. Actually, everything we've been doing, it's really easy. Just set your mind here. Guys, the power of setting your mind and focusing is really powerful. Just focus and you will see that these things, they're actually very easy. Nothing is difficult here. Just focus and you'll see the results. Nay, you remember yesterday we talked about sharing things. Learners were sharing biscuits and others were sharing apples, and you receive what you have contributed. For example, let's say a bag of 20 apples, and that bag of 20 apples, it's 10 rand. Let's say it's 10 rand, and there's 3 of you guys, you and your friends, and you contribute 2 rand, your other friend contributes 3 rand, and your other friend contributes 5 rands, for example. Guys, the one who contributed the less will receive less apples. You remember, right? So if you contributed more, you will get more apples when we do our calculations, right? So what I'm trying to say is that if you focus more, you will get more results. If you focus less, you will get less results. That's how it is. Thank you guys so much for joining me. So let's get into this, right? Okay, we are doing our corrections. So for number two, it says the journey from his head office to town where he plans to start a new business takes Mr. Hotzo 4.3/4 hours. That's how many hours he takes to go to town where he wants to start his new business, apparently. The amount of time he spends in town is equal to 4/5 of the time it takes him to get there. So basically, this question, guys, maybe some of you are a bit confused, but I will make this example. So let's say that for you to to go to school. Maybe it takes you, let's say it takes you 35 minutes. Nay, we can say it takes you 35 minutes. This is the example so that you can understand the question. It takes you 5 minutes to get to school. And you spend 1/2 of your time waiting for the taxi maybe, or waiting for your mom to get ready. And it takes you half of the time waiting for your mom. So guys, how long does it take you, like in minutes? How long will you wait if it takes you 1/2 of your time to wait for your mom or your taxi? And it takes you 35 minutes to get to school. So how many minutes are you going to wait there for? Are you going to wait for those people? How many minutes are you going to wait? So this question basically says that this person takes 4. Okay, let's not use fractions, for example. Let's say it takes this person 4 hours to go to town, and he spends half of his time there in town. He spends half of the time in town. So it means that if it took him 4 hours to town and he spends half of his time, what is that half of his time? What is half of his time? It's 2 hours, right? So this question basically it's saying that, and again, don't get confused by the fractions. It's the same. It's the same, guys. Don't get confused or stressed out now because you are seeing fractions now. No, it's actually the same. So question number 1, they're asking us 2.1. How long does he spend in town? So guys, how long does he spend in town? Are you going to multiply or divide? Let's use this example right here. It takes 45 minutes to go to school and you have to wait for your mom half of the time. So how long do you wait for your mom? Are you going to multiply or divide? How long do you wait for your mom to get ready or for the taxi? How long do you wait for your mom to get ready or for the taxi? That half of the time. Are you going to multiply to get the number, the hours or the minutes that your mom gets ready, or the taxi, the time you have to wait for the taxi? Are you going to multiply or divide? That's question number 2.1 for us. Are we going to multiply or divide? Let's see fast. Guys, are we going to multiply or divide? Are we going to multiply or divide? Okay, guys, let me repeat the question name because it seems like you guys are not getting it. Okay, so what I'm trying to say is this person, for example, takes 4 hours. You take 4 hours from here to Devon, let's say that, and you spend half of the time in Mentros. You spend half of your time in Mentros, half of the time is spent in Mentros. How long is that half of the time? Are you going to multiply or divide? Are you going to say 4 hours multiply by half so that you can see the amount of time you spend on your stop? Or are you going to divide? For example, like this one, we will multiply, guys. We'll say 35 multiply by half, which is how much? Which is 17, I'm using a decimal so that you can understand, which is 17 and 5 minutes. you will multiply. Ne? So now let's do the first one. We are going to multiply, guys. We are not dividing. And you see right here, they say the time he spent in town is equal to 4/5 of the time it takes him to get there. So it means that the time will be closer to, because it's 4/5, it's a lot. It's close to everything, like it's close to 5/5. 4/4 is close to 5/5. So it means that our answer will be close to 4 and 3/4. Do we understand? But let's do it so that you can understand. So let's have our calculations right here. Let's check again. Yes, we multiply, guys. I hope you understand that one. We are not dividing, we are multiplying. Nay, please don't make that mistake. And since that he spends 4/5 of in town, so it means that our answer will be close to this one. It can probably be 3, you see, because it's 4/5 of this, and it's basically saying multiplication. You remember BODMAS, guys. Of equals to multiplication of multiplication sign. So let's do it then. We have 4 and then 3/4 multiply by 4/5 equals to, you know that we say 4 multiplied by 4 plus 3. So 4 multiplied by 4 equals to 16. 4 by 4 equals to 16. 16 plus 3 equals to 19. And you know that we keep our denominators. Our denominators do not change, right? So over 4 multiply, of course, by 4/5, because this one is already a common fraction, right? So now let's multiply. Let's multiply then. When we do multiply, guys, you remember that we must get our highest common factor, right? We must simplify first before we can multiply. So guys, when we do simplify, we look at the opposite numbers, right? We look at the opposite numbers. Here's our fraction. So what is our highest common factor? Like for 4 and 4, our highest common factor for opposite numbers. You look at the opposite numbers. 4 is opposite to 4, 19 is opposite to 5. So what is the highest common factor for 4 and 4, and what is the highest common factor for 19 and 5? So the highest common factor for 4 and 4, obviously, it's 4 and 4. So it's 4, guys. Like that one, we don't have to scratch our heads. It's 4. Highest common factor for 4 and 4 equals to 4. So we'll divide this 2/4 by 4. And our highest common factor for 19 and 5, we don't have it. We don't have a highest common factor for 19 and 5. It's only 1. And 1 won't change anything, right? So let's do it then. We'll say 19/1, because 4 divided by 4 equals to 1, multiply by 1/5, because 4 divided by 4 equals to 1. That's our new equation, right? So now we'll say 19 multiplied by 1, which will give us 19, obviously, and 1 multiplied by 5, it will give us 5, right? Okay, guys, you see that this, like, it's like working with whole numbers, guys. It's just that in this case, you are working with fractions, and when we multiply fractions, this is how we do it. Okay, now let's have a mixed fraction then. we want to see how many hours does this person spend in town, because the amount of time he spends in town is 4/5 of 4 hours 3/4. This is how the amount of time he spends in town. Ne? So tell me the mixed fraction for this one. The mixed fraction, because it's an improper fraction, right? So you must get how many hours he does spend in town. So what is our mixed fraction for 19/5? I think this one, guys, all of you must get it right. Like this one, all of you must get it right. So our mixed fraction for 19/5. Okay, guys. So our mixed fraction for 19/5, how many times does 5 goes into 19? How many times? It goes 3 times, right? So after that, what will be the remaining number or the remaining amount? What will be the remaining amount after our 5 goes into 19? What will be left behind? What will be the amount left there after taking our 5s, which goes 3 times? The amount that will be left, it will be 4. Name 4, and then we keep our denominator. So this person, which is Mr. Khotso, spent 3 hours and 4/5 in town. This is the final answer. Name. Okay, so now let's go to the next question. So let's clean our slate. Let's go to the next question. So the next question, it says, at what time does he return to the head office if he arrived at town at 11:15? So let's say that you spend your time at the mall basically for 2 hours. Ne? And if you arrived at the mall, let's say you arrived at the mall at 10 o'clock, what time are you going to leave the mall? You spent 2 hours at the mall and you arrived at the mall at 10 o'clock. When are you leaving the mall? What time are you going to leave the mall? Because you only spent 2 hours there. What time are you going to leave the mall, guys? This is the same question. Guys, can you please answer the question? We'll discuss the issues later in our Google Classroom, the issues we are talking about. What time are you going to leave the mall? Let's say you arrive at the mall by 10 o'clock, ne? And you only spend 2 hours at the mall. What time are you going to leave? Irene, thank you so much. Thank you so much. So you will arrive at the mall, you will leave the mall by 2 o'clock, right? So this person obviously spends how many hours? He spends 3 hours and 4/5 minutes in town, basically. So if he arrives at town at what time does he leave to return to the head office? So we'll add this. So we'll have 11 plus 3 hours, which is 14. And you know 14 is what? 14 is 2 o'clock. And let's also keep our 15 minutes. Let's finish this up right here. Okay, so and then what we will do is that we'll convert this, because guys, this topic about time, it's a topic on its own. So we'll convert our 4/5 to a decimal. 4/5 to a decimal equals to 0.8. And we'll treat this 0.8 as our minutes, because we have hours, which is 3 hours. So the fraction will convert it, we'll use it as our minutes. So how many minutes do we have? We only have 8 minutes, 3 hours and 8 minutes. So our answer here will be 14. Guys, this one, we didn't really have to answer this one because I would like us not to focus on time. But that's our answer, 14:23. Guys, I can't find a rubber here. Don't know what is happening. Okay, what is it now? Okay, guys, we can't find the rubber. It's fine. So let's move on to number 3. So number 3, it's saying how many pieces of rope of 1 and 2/3 meters long can be cut from a roll of 95 meters in length. So basically this one, guys, this question right here, are you going to multiply or divide your question? So this question right here, for example, it's saying that, let's say you need, we have 30 meters long of a ribbon maybe, and it's my weighting, guys, and this ribbon, it's 30 meters, and each ribbon that we need to get from that 30 meter ribbon, we need 3 meters, to make each ribbon. How many ribbons are we going to receive from that 30 meter ribbon? Because each ribbon must be it must be, okay, let's do it right here, guys. So let's say this is my example, 30 meters ribbon, So let's say we have a 30 meter ribbon right here. So since we have a 30 meter ribbon, to make ribbons, we will need, for each ribbon, we will need 3 meters. How many? So guys, let's answer this question then. 30 meters of ribbon, like that, it's a long, let's say it's long, we are going to make ribbons, and this fabric is 30 meters, and from that fabric, we are going to need 3 meters to make a ribbon, how many ribbons will we receive from that 30 meters? Are we going to divide or multiply? That's what I'm trying to ask. What is the answer for the question that I gave you right here? We are going to divide, guys. So yes, we are going to divide. So our answer will be 10 ribbons. So let's do the question right here. So we had 95. This is how we'll do it. This question we will divide by 1 and 2/3 equals 2. So first thing first, guys, you know that we need to convert, right? We need to convert our mixed fraction to improper fraction. So 1 multiplied by 3 plus 2. So 1 multiplied by 3 equals to 3. 3 plus 2 equals to 5. Then 5 over, we keep our denominator, right? And you know, guys, when we divide our fractions, you need to swap. Do you still remember that when you are dividing our fractions, you need to swap? You need to swap first after converting it to your improper fraction. So now let's swap. We swap the second fraction, the second fraction. So this one we don't swap. We'll say when we swap and we put our multiplication sign. So when we swap, we will have 3 on top and then we'll have 5 just right here. And you know that when we multiply, we must simplify first. You can simplify now or after multiplying your fractions. So let's simplify this one. I like it when we simplify before we can multiply. I think it's easier in that way, guys. So now let's simplify. We must simplify the opposite numbers. We have 1 and 3, right? And then we also have 5, 95, and 5. Now we can't simplify 1 and 3 because their highest common factor is 1. And 1 won't change anything. So the highest common factor for 95 and 5 is what? It's 5. So we'll divide with this 5 by 5 and 95 by 5 equals 2. So let's do it then. 95 divided by 5 equals to 19, 19 over 1. And then we'll obviously multiply it by 3 over 1. Let's write it neatly here. So our new fraction will be 19 over 1 multiplied by 3 over 1 equals 2. So let's do this one then. Obviously, we'll say 19 multiplied by 3, it gives us 57, and 1 multiplied by 1, it gives us 1. So our answer will be 57 over 1. And 57 over 1, which when it's simplified, it's basically 57. Guys, let's write our final answer just right here. So our answer for this one will be 5, 7. Now, let's read the question and understand. So the question was, how many pieces of ropes of 1 and 2 over 3 meters long can be cut from a roll of 95 meters in length? So the answer is 57. 57 pieces of ropes can be cut from a roll of 95 meters in length. So the answer for number 3 is 57. 5, 7. Right. So now let's go to number 4.1. So number 4.1, it says 3 students read a book out loud so it can be recorded on a DVD for the blind. Name. So maybe you and your classmates, you and 2 of your classmates are going to read a book, and that book will be recorded on a DVD so that the blind people or blind learners can hear the book because they can't see to read the book. So you are recording your voices while reading the book. And the second statement says they take 7 and 1 over 5 hours to read the book. That's the total hours they take to read the book. Now, maybe now you're asking yourself that how long is each person allocated, like the distribution? And the third statement is saying, for how long does each person read if they all read for the same length of time? So when they say for the same length of time, they basically means if they take the same time for example, let's say all those 3 students, the total hours is 6 hours, and they read for the same time. All of them, they take the same time of length to read. So it basically means 6 divided by 3, and that will give us 2. Each person 2 hours. So equally, they have equal time. Their time is not different. They have equal time. So the question is, for how long does each student read if they all read for the same length? So we must now divide. We must divide this total time right here by 3, because we have 3 students. We only have 3 students, so we must multiply this total time here by 3 students. So let's do it together. So the total time was 7 hours and 1/5. We are dividing it by the number of students, and the number of students is a whole number. And when we do have a whole number and we are working with fraction, you'll just simply say 3/1. So after doing that, guys, you know that you must convert your mixed fraction to your improper fraction. So you will say 5 multiply by 7, and that will give you 35, and then 35 plus 1 equals to 36. So you'll have 36/5 divide by 3/1. And you know that when we are dividing our fractions, we must swap. On our Kahoot game, there was this question that you need to swap. So we need to swap, but then the first fraction, it stays the same, 36/5. And then when we swap, we also put our multiplication sign, and then we'll have 1/3. Right. So now, since we have 1/3, now we need to simplify. So when we do simplify, we must find the highest common factor. So for the opposite numbers, which is 3 and 1, we can simplify them. And again, we have 36 and 3. 36 and 3, we can most definitely simplify it. What is the highest common factor for 36 and 3? It's 3. So we'll say 36 divided by 3 and 3 divided by 3, because it's our highest common factor, and our new fraction will be 12/5. No, here it's 5. Sorry, guys. 12/5 multiply by 1/1 equals, and then we'll multiply it. 12 multiplied by 1 equals to 12. 5 multiplied by 1 equals to 5. So this is our improper fraction, right? So you know that our improper fraction, most definitely we need to convert it to our mixed fraction to see how many hours does each learner read. That was the question. So how many times does 5 goes into 12? 5 goes into 12 how many times? Only 2 times. And what will be the remaining number after that? The remaining number after taking our 2 5s, which makes it 10. What will we leave behind? We are leaving 2 behind. And you know that we keep our denominators. And this is our answer for each learner. Each learner reads for 2 hours and 2/5 hours. So this is our answer for number 4.1. All right. So now let's move on to the next question. Let's clean the slate. The next question we have, what does it say? The next question is, a second group of 4 students read another book out loud for recording in 6 and half hours. So now we are dealing with 4 students who are also recording a book, and the total time they all take is 6.5 hours. Each of the students read for the same length, equal time for everyone. How much longer does each student in the first group read more than each student in the second group? So first thing first, before we can see the difference, because now they're asking us the difference, which is subtraction, right? So before we can see our difference, we must find out first the second group. Each person will be allocated how long, right? So let's do this equation right here. So obviously we'll have 6.5 hours divide by 4 students, right? So let's do it together. So we have 6.5 hours divide by 4 students. Since we are working with fractions, you know what we do, and we need to convert this one. 6 multiplied by 2 plus 3, it gives us what? We'll have 13 over 2 divide by 4 over 1. And we need to swap. But we're only swapping the second fraction, multiply by 1 over 4. Right, so we'll say 13 multiplied by 1, it will give us 13 over 2 multiplied by 4, that will give us 8. Now we need to convert this to a mixed fraction. So when we do convert this to a mixed fraction, how many times does 8 goes into 13? It only goes one time. And what will be the remaining number? The remaining number will be 5, and we keep our denominator. So this is for the second group. This is for the second group. So the second group, each person, because they are 4, remember? So each person spends 1 hour and 5 over 8 to read the book. So the question was, what is the difference, right? The difference time that they read. The difference, they were asking us for the difference. So now let's have the fraction for the first group. So the first group, they took longer. They took 2 hours. Each person took 2 hours over 5. We are subtracting it by the second group, which is each person only took 1 hour over 8. So we need to subtract this. But first thing first, we need to convert it to our improper fraction, right? So we'll say 5 multiplied by 2 plus 2 will give us 12 over 5 minus 8 multiplied by 1 plus 5, and that will be 13, and we keep our denominators. And remember that when we're subtracting our fractions, we must get our lowest common multiple, which is called as LCM. So our LCM in this case, what is our LCM for 5 and 8? What is our LCM for 5 and 8? Guys, what is our LCM for 5 and 8? So our LCM for 5 and 8 is 40, right? It's 40. So we need to multiply again. So since it's 40, how many times did we move in the multiples of 5 to actually reach 40? And how many times did we move in the multiples of 8 to actually reach 40? So in the multiples of 5, how many times did we move? We only moved 8 times. So since we only moved 8 times, we'll multiply it by 8. We'll have 12 multiplied by 8 over 5 multiplied by 8 minus 13 multiplied by 5. In the multiples of 8, we only moved 5 times. Multiply by 5. And that will give us 96 of 40. Subtract 65 over 40. And then we keep our denominators. Obviously, we keep our denominators. And then we'll say 96 minus 65, and we'll have 31. So this is our proper fraction. And our proper fraction, we can convert it to an improper fraction, right? To a mixed fraction, sorry. So let's go to today's lesson. Like, the time is moving so fast. Wow. Okay, guys, so for today, we'll only tackle this for 5 minutes. We've already done this. So most of you guys are familiar with equivalent fractions. So what are equivalent fractions? Equivalent fractions are fractions that have the same value even though they look different. All right. So for example, right here, I have 36 over 42, ne? And they say that 36 over 42 is equivalent to 6 over 7. So it basically means that, let's say a fraction is simplified, it still has the same value as the fraction that is not simplified. Now, you see here, this is our equivalent forms. They basically simplified this fraction. And then again, here on this first picture right here, we have 4 over 8, which is equivalent fraction to 8 over 16. You basically, when you want your equivalent fractions, to find an equivalent fraction, you multiply the denominator and the numerator by the same number. Guys, what we just did, finding the lowest common multiple, we were finding equivalent fractions. You see that? Because we were multiplying the fraction, the same number, to the denominator and the numerator. To find our equivalent fraction, we multiply the numerator and denominator by the same number. So let's look at this table right here. So this table right here, you see we have 1 over 2, which is half 1 over 2. So 1 over 2, it's equivalent to 2 over 4. Right, it's equivalent to 2 over 4. It's the same. When you simplify 2 over 4, you will get 1 over 2. Right, and again, 2 over 4 is also equivalent to 4 over 8. When you simplify 4 over 8, you will get 2 over 4. And also, when you simplify 4 over 8, you will also get 1 over 2. That's our equivalent fractions, right? So we have, I wanted us to do this activity right here. So this activity, let's just answer this one right here. So complete the following fractions. I will upload these slides, guys, on our Google Classroom. And for the rest of the weekends, we'll talk there at Google Classroom. We'll talk there. So in this case, what is the answer for number 1? The answer for that open space, guys, before we end our lesson, the answer for the open space, what is it going to be? It's going to be 4, okay? It's going to be 4 over 8. So this is our answer. It means that they multiplied both of the numbers by 4. Now, our answer will be 4 because it seems like they multiplied the numbers by 4. because 2 multiplied by 4 equals to 8. And when they are equivalent fractions, the numerator and denominator must be multiplied by the same number. So 1 must be multiplied by 4, and 2 must be multiplied by 4, and that's 8. And then we'll have 4 over 8. 4 over 8 is equivalent to 1 over 2. So now okay, guys, I wanted us to do the last one, which is number 2, because the time is up. Number 2, they basically said 2 multiplied by 3 equals to 6. So it means that we'll say 3 multiplied by 3, because we must multiply with the same number to get our equivalent fraction. We must multiply the numerator and denominator by the same number. So this is our number 2, and this is our number 1. Guys, thank you so much for joining me today. I will see you again on Monday. On Monday, same time, guys, same time. Let me put thank you so much, Tanisha. You enjoy your weekend too. Guys, for those who didn't join our classroom, guys, Google Classroom, please join Google Classroom, guys. It's really important, ne? Join our Google Classroom, please.